Hello guys, this is SURD part 3. Okay, we are going to dive deep into into some logic and some valid SURD form in mathematics. So what we're doing now is SURD part 3. Okay, so on this part there's what we call valid SURD, and there's what we call invalid SURD. Okay, so for valid SURD, let's say we have let's say valid. Okay, don't let us go straight to valid, then we can combine both of them together instead of us doing valid alone. Okay, so in this case now, what we can just do is that let's just say my let's say my A equals, let's say, 27. Okay, let's say my A equals 27, or I can say my A equals let's say 81. Let me just say 81. Let me just say 81, and I can say my B is equals let me just say 4. Okay, now for us to define valid SURD and invalid SURD, so in SURD we can do addition, we can do subtraction. So we wanted to confirm the validity of the addition, the subtraction, the division, or the multiplication. So for instance, example A, let's say example A, we have A plus B, is it equals to A, square root of A plus square root of B. So we wanted to confirm the validity. So if it is not equal, then it means it's invalid. If it is equal, then it means it's valid. So for B, we'll say that, okay, yes, let's say A times B, is it equals to, okay, is it equals to A times root B? So that's another one that we'll also be discussing here. So then for C, don't forget, is it equals to or not equals to? Okay, or not equals to. Do you understand now? So is it equals to or not equals to this? Is it equals to this or not equals to this? So for C, we can say that a over b a over b, is it equals to root a over root b, or not equals to. Okay, so that's another part of it. So now for let's say for now, let's take the first one before we move to the other one, though we have this part that is called D part. So the D part, we can say that, okay, let's say if we have let's say root a over b square, is it equals to root a over root b square? Okay, what we're just trying to do is just to split this. Now don't forget what we have here. We said that a is equals to 81, b is equals to 4. So anywhere you see a, put what? Put 81. Anywhere you see b, you put what? 4. Then the same thing applies here. So we can now say that this implies, for the first one here, this first one will give us, that's 81 plus 4. Okay, so that is the meaning. So it means for this first one here, that is a plus b, that's a plus b. A is equals to 81, b is equals to 4. So instead of me writing a, I write 81. Instead of me writing b, I write what? 4. So therefore I can say, look at this now, is it equals to or not equals to, let's say, root, that's 81, that's plus root 4. So from my answer here, I can say that, okay, 81 plus 4, that is root 85. Okay, then from here I can say equals to, that's 81. 9 times 9 is what? 81. So I can find the square root of this, which is what? 9. Okay, I can say plus or minus because of this square root sign. Plus, what is the square root of this? That's 2. So it means that root 85 is not the same thing as what? Root, it's not the same thing as plus or minus 9 plus what? 2. So I can remove this because don't let us complicate things here. So which means that root 85 is not equals to this. So this now tells us that from here we can see that instead of us saying it's equals to, then it means that it's showing that this is not equal. Why is it not equal? It's not equal because by the time we substitute A is equals to 81, B is equals to 4, in both cases, in this case and in this case, at the end of the day, we are getting different answer. So because we are getting different answer, it shows that they are not equal. So the same thing applies here. If we say for this number, that's the B section, that is if we have 81 times, that's 4. Okay, so are we going to say is equals to or is not equals to, that's 81 times root 4? Okay, so now 81 times 4, by the time we do this, 4 times 1 is 4, 8 times 4, that's 32. Okay, so it means this one is root 324. So which implies that by the time we simplify this one will give us 9, then this one will give us 2. 9 times 9, 81. 2 times 2 will give us 4. So 9 times 2 is equals to what? 18. So it shows that 18 is not the same thing as what? It's not the same thing as 324. So then it shows that by the time we divide this, let's say we have 2 here, that's 2 here, 1, 2 here, 6, 2 here, 2. Okay. Then we have, that's, we can say 18 times 18, 8 times 8, 64. We carry 6, 8 times 1, 8, 8 plus 6, that is 1, 8 plus 6, that is 14, that's 18. Then you have 1, that's 4, that's 2, then you have 3 to 4. So now if you look at it very well, it shows that 18 times 18 will give me 3 to 4, and we got 18 here. So now let me correct myself. It shows that from here the square root of 3 to 4 is 18. The square root of 324 is 18, which shows that this is valid. Then this is the correct answer. That is, square root of A times B is equals to square root of A times square root of B. I hope it's clear now. For the first one, so it means that this first one, because it's not equals to, is called invalid SURD. Now, for this second one, because the answer is equals to, this one is called valid SURD. Okay, so we can do the same for A over B. I hope this one is clear. If you look at it very well, don't get confused. A times B, 81 times 4, which is this, 81 times 4. 81 times 4 will give us what? 324. So what is the square root of 324? It is what? 18. Because 18 times 18, by the time you do your calculation, will give me what? 324. 8 times 8, 64. Carry 6. 8 times 1, 8. Plus 6, that will give you 14. 1 times 8, 8. 1 times 1, 1. Then by the time you add it together, you have 4. Then you have 12. Then you have 324. So which shows that is what? 18. So 18 is equals to 18. The square root of 81 is 9. Square root of 4 is 2. 9 times 2, 18. So it shows that this one is equal. And this one is tagged as what? Valid SURD. So here too, if we do the same here, if you look at this one, let's say, okay, let me clean this part. I believe you understand this. So we'll still solve more than enough questions. It's not how far, but how well. So, but I'm just trying to explain this one to you. So, from what we've done so far, that this one is invalid sort. Okay. So by the time you look at this now, A, that's 81. Then you have A is 81. Then you have B to be what? 4. So we want to decide whether it is equals to or not equals to. Now from here, we can say, okay, equals to or not equals to. We'll decide. So from here, we can say square root of what? That's 81 over square root of 4. So very clear. Don't miss it. This part is this. Okay. This second one is this second one here. Okay. So now square root of what we just need to do here before you find the square root, which means that we need to look at what can go in both of them. So if you look at this very well now, you can say 81 divided by 4, it cannot go. If you say 4 here and 8, that is what? 4 and 8 is 2. So 4 cannot go in 1. So it means it's not going to work because you cannot divide it. Okay, but if you look at this one, you can divide the square root of 81 is what? 9. Then square root of 4 is what? 2. So it means that root 81 over 4 is not the same thing as what? 9 over 2. It's as simple as that. Okay, because I cannot divide 81 divided by 4. So definitely they are not equal. So it shows that this one, the answer of this one is what? Invalid sort. That's invalid sort. Okay, invalid sort. So it's more or less like a discussion just to verify before we, just to verify that how do you can you add sort, can you subtract sort, can you divide sort, can you do this? So like now in this case now I can say is A, I can just say A minus B, is it equals to or not equals to A minus separate. Okay, so this is D, this is example E now. Okay, I'm yet to come to this D part, so I just wanted to tell you because I've explained the addition. So now for A is 81. You can just come here and say 81 minus 4 equals to or not equals to, that's 81 minus, that's 4. So if you look at this very well, 81 minus 4 will give you something like 77. Okay, which shows that square root of 77 equals to or not equals to. So square root of 81 is what? 9. Square root of 4 is what? 2. So 9 minus 2 will give us 7. So now square root of 77, is this the same thing as 7? No. So which shows that this does not work. So this will fall under invalid sort. So it means that you cannot add sort together because it has condition. That is the meaning. In sort, you cannot add it. You cannot do what? You cannot subtract it. But you can what? Multiply it. Look at the multiplication sign here. It means that you can multiply, which is valid. So what this invalid is telling us that you cannot add sort together except if you obey the condition. Now, what this part is telling us that you cannot subtract sort except you maintain the condition before you do it. Then this multiplication is telling us that you can multiply sort without maintaining the condition. Okay, now for number C, it's also invalid sort, which it tells us that you cannot just divide sort without maintaining the condition. So that is root A over B is not equals to root A or over root B. That is the meaning. So let's quickly deal with this last part, which is this number D. Because of the space, we don't have much space here. I believe you're following. By the time we start solving examples now, you will understand exactly what I'm saying. Then for number D, you have that's D here. For D, you have, what is my A? Don't forget A is 81, then B is what? 4. Then it means you have 81 over, that's B, which is 4 square, equals to root 81, which is this here, root 81 over, that's 4 raised to power 2. Now, if you look at this very well, 4 raised to power 2 is same thing as 4 times 4, which is 16. So this one will give me 81 over 16 equals to, don't forget, we are testing whether it's equals to or not equals to. The same thing happens here, equals to or not equals to. Okay, now, square root of 81 is what? 9 over, don't forget, in SURD, this square, aside the fact that it means plus or minus, sometimes it can also mean like this: 4 raised to power 2 times half. That's indices. We'll still get to that. Okay, so it means I can cancel these two together, so I can now have, that's root 81 over 16 equals to or not equals to 9 over 4. Two has cancel each other. It means these two will cancel this square. So you can now have ordinary 4. So if you look at it very well, 81 over 16, what can go here? I can't see anything that can go here. 9 can go here, but 9 cannot go here. So it means I can leave this like this. If you look at it very well, root 81 over 16, is it the same thing as 9 over 4? No. It shows that you cannot divide, this. This is not equals to, it means that this is not equals to, this is the answer, that is root a over b square is not the same thing as root a over root b square. So it means this is the correct answer, which is the second part, which is this one. So this is not, you can't equate it. So the only thing you can do here for now that is valid is multiplication. All the other one, which is the addition, which is the subtraction, and this division part, they are not equal and they are classified under invalid. Okay, by the time we start solving examples, then we will know that yes, you will understand it better. So this is the part of this, this is part 3. Then the next topic, the next class is going to be solving of problems, solving of examples, so that I can explain this, then you can get the understanding of what this part is all talking about, the valid SURD and the invalid SURD. Please like, share, and comment, and ensure that yes, we get this interaction going, we get this energy going, so that we can continue to give you the best in terms of mathematics, mathematics SURD in mathematics. Thank you very much.